Hey there, and welcome to yet another opportunity to learn something in algebra. So here we go. We're in section 1.4 talking about complex numbers. And complex numbers are introduced in a variety of ways. We're going to just basically learn about them. They're very simple. They're not complex, quote unquote. The reason they're called complex numbers is because they have two parts. Right, they have a real part, which we've dealt with real numbers for a long time, and then they have what's known as an imaginary part. It's an unfortunate name. Historically, that comes from the fact that the guy that discovered it was about 24 years old when he discovered imaginary numbers, and a lot of mathematicians at that time thought he didn't know what he was talking about, and so they called them imaginary numbers as kind of a joke on him, and the joke was on them actually, because he was right. So his name was Gauss. Gauss was probably one of the top 5 mathematicians ever in the history of math. So they didn't know that at the time. He was just 24. 24 when he finished his PhD, and so that should have given them a little bit of a clue, but anyhow, whatever. So we're going to talk about complex numbers. They have their own rules. If you'll follow the rules, they're easy. Okay, so let's talk about what those rules look like when we add and subtract first. All right, so once again, they're complex numbers because they have two parts. The first part is the real part, which is A, it's a real number, and then B times I is the complex or the imaginary part. I represents a number whose square is -1. I is not really, the definition of I is not square root of -1. That's a consequence. The definition is the number whose square is -1. For you guys, it doesn't matter. You can think of it either way. There is a little bit of a mathematical difference between those two definitions. And so the standard form of a complex number then is A plus BI, where again, A is called the real part, and the BI is called the imaginary part. Okay? All right. So how do we mess around with the complex numbers? To add and subtract and to multiply, we basically think of them as binomials, right, as a two-part deal. So if you have x plus 2y and you want to add 3x minus 4y, then what do? You combine the x's and you combine the y's, all right? And then you have parts with x and parts with y. Well, that's what we do with the real part and the imaginary part. That's exactly how we handle it. So if you're adding 5 minus 2i, so this is one number. That's one complex number. This is a second complex number, and when you add two complex numbers, you have to get a complex number. And so you take the 5 and the 3, you add those together, that's the real part, 8. You take the -2i and the +3i, and you pull the I out, and you take -2 plus 3, and you get -1, or +1, excuse me. And so you get 8 plus I. That's one number, right? And that's the answer when you add those two together. If you want to subtract, all right, same idea. 2 plus 6i minus 12 minus I. The first thing you do, of course, is you distribute the negative sign through, because when you're adding and subtracting, when you're adding it doesn't matter, but when you're subtracting the whole number, which means you have to distribute the negative sign, and it changes and makes this a plus I. So you get 2 minus 12 for the real part, you get 6 plus 1 for the imaginary part, you get -10 plus 7i, again, two parts, one answer. Okay? Very straightforward when you add and subtract complex numbers. Multiplying is not much different. If you want to multiply a complex number times a single monomial, we distribute 7i times 2 is 14i. 7i times 9i with a negative is -63i squared. But remember that I squared is -1. And so when we see I squared, anywhere we see an I squared, we substitute in a -1, and then we do order of operations. Multiplication comes before addition. So 63 times -1 is plus 63. The two negatives make a positive. And then we write it in standard form, which is the real part first and the imaginary part second. Okay? if you want to multiply two complex numbers, which are full complex numbers, 2 parts each. Well, how do we multiply binomials? We do the FOIL method, right? Well, that's what we're doing here. We're doing the FOIL method. So we're going to take 5 times 6, or we're going to take 5 times negative 7i. We're going to take 4i times 6, and we're going to take 4i times negative 7i. We're going to FOIL it. That's all we're doing. Okay? So as we do that, right, you get 5 times 6, 5 times 6 times 5 plus 5 times negative 7, I plus 4i times 6 plus 4i times negative 7i. So here's the first one, F, goes like that. The inside one goes like this. All right, and so as we simplify that further, 30 minus 35i plus 24i minus 28i squared. Again, remember I squared is negative 1, so now we're going to plug a negative 1 in for that I squared. We simplify the i's, negative 35, and 24 is negative 11. And now we get negative 28 times 1, negative 1, which is positive 28. And so we get 58 minus 11i as our final answer. And again, when you're adding and subtracting real numbers, or excuse me, complex numbers, you got to get a complex number as your answer. Okay? So, with that in mind, let's take a look at division, because division is not as obvious. In order to talk about division, we're going to talk about what's known as the complex conjugate. And the complex conjugate for a plus bi is what's a minus bi. So it's the conjugates of one another are the same numbers, opposite signs. So if you have 2 minus 3i, the conjugate of that is 2 plus 3i. If you have 4 plus 7i, the conjugate of that is 4 minus 7i. It's the exact same numbers with the same everything. A is the same number exactly. If it's a negative, if this was negative 4, this would also be negative 4. Okay? It's the same A, and the B is the same. You just switch the sign in between. That's all you do. Now look at what happens when you FOIL this out. If we FOIL this out, we get a times a, which is a squared. You get minus abi and plus abi. And then you get b squared I squared. Well, minus abi and plus abi gives you 0. I squared is negative 1, and so you get a squared plus b squared. There's no I. And so this becomes real only. Now, before you get smart on me here, all right, I did say that every complex number operation has to end up with a complex number, but remember, every real number is a complex number. 5 is complex if we write it as 5 plus 0i, right? There's all real numbers are complex numbers, right? They're just complex with a 0 imaginary part. All right, so that's still okay. Still complex. All real numbers are complex numbers. So how do we divide? We divide by getting a real number in the denominator. We don't want i's in the denominator. Dividing by I is weird. And so in order to do that, if we have a fraction, we multiply the top and the bottom by the conjugate of the denominator, because when you multiply by the conjugate, you get real only. Okay? So, first of all, what are we going to multiply by here? Well, what's the conjugate of 4 minus I? The conjugate of 4 minus I is 4 plus I. But if you do it to the bottom, you got to do it to the top. Don't forget that these guys are in parentheses, even though they're not written that way. And now we distribute everything. We double FOIL. FOIL the top, FOIL the bottom. So we get 5 times 4 is 20, plus 5 times I, plus 4 times 4i, which is 16i, plus 4i squared, that's on top. On the bottom, we get 4 times 4 is 16. We get a plus 4i and a minus 4i in the middle. And then we get a negative I squared. Okay, so these guys subtract to give you 0. The top becomes 20 plus 21i plus 4 times negative 1. The bottom becomes 16 minus negative 1. And so we get 20 plus 21i minus 4 over 16 plus 1. Negative negative makes a plus. And so if you combine the numerator, you get 16 plus 21i. The denominator is 17. And now that's still not in the proper form. The proper form is supposed to be a plus bi. And so in order to do that, we get 16 over 17 plus 21 over 17 times I. That is technically the complex number version of your answer. And this is the way it needs to be written. You can't leave it as one fraction. You need to break it up into the real part and the imaginary part. Okay? So that's the process of dividing complex numbers. When you see two complex numbers divided by one another, or anything with an I in the bottom, even if it was just 7 divided by 4 minus I, you would still, okay, you would still do the same process. Okay, I'm going to do one more example because I think you need to see another one. Okay, and so a second example here would be 2 divided by 3 plus 4i. Okay, still what we're going to do is we're going to multiply by the conjugate, top and bottom, 3 minus 4i, 3 minus 4i. And so this 2 gets distributed, or will get distributed here in just a minute. This guy is FOILed out. You get 9 minus 12i plus 12i minus 16i squared. Okay, we distribute the top out. We end up with 6 minus 8i on top. On the bottom, we have 9 minus 16 times negative 1. So we get 6 minus 8i over 16 plus 9 plus 16, which is 25. And then if we break it up, we get 6 over 25 minus 8 over 25i. Okay, so it's the same process whether you have a complex number on the top or just a real number on the top, or just a simple imaginary number on the top. It doesn't matter. You have to use the conjugate of the bottom. Okay, that's how we do it. And finally, principal square roots. Remember, when you see the square root of a negative number, it's not a real number. That does not exist, but it does exist. It's just not real, right? We put no real solution for a square of a negative number. So when you see the square root of negative 16, the first thing you do is put an I out front. That negative number, you think of it as a negative 1, and you pull it out as an I. And then if you can simplify it further, square root of 16 is 4, then you do it. Okay? But the I's got to come out first. The very first step every time is to take out that I. Okay? So if you want to add these together, the first thing I do is make this I square root of 27 plus I square root of 48. Now, how do you handle these guys? These break down. 27 is 9 times 3. 48 is 16 times 3. And so we end up with I square root of 9 times 3 plus I square root of 16 times 3. Square root of 9 is 3. Square root of 16 is 4. So we have 3i square root of 3 and 4i square root of 3. So that gives me a total of 7i square roots of 3. That's a 7. And that's your final answer. Okay, so once we pull the i's out, then it's just basic square root rules. And I understand that some of you guys maybe got a little lost from here down. If you did, all right, then you need to go back and take a look at the beginning. I think it's section 1, P2, section P2. We didn't do it in class, but there's certainly some problems that you can practice on there to help you remember how to break down your square roots. Okay. A second example of this, if you have negative 2 minus the square root of negative 3 squared, you must do this to an I first. You don't do anything else until you make that an I. Okay. Now, how do you square this out? You do not distribute the square. You don't do that. You FOIL it. So you have to write it as negative 2 minus I square root of 3 times negative 2 minus I square root of 3. And then you FOIL it out, and then you simplify. you get a plus 2i squared of 3 and another 2i squared of 3, then a plus 3i squared. Remember, square root of 3 times itself is 3. I times I is I squared. And so you get 4, you get 4i square root of 3's, and then you get 3 times negative 1 from here. And then that's negative 3, 4 minus 3 is 1. And so you get this as your final answer for squaring negative 2 minus the square root of negative 3. But again, the first step, that's the key. That's the first step. All this stuff right here, that's just basic algebra with the I squared. Okay? So hopefully that's not an issue. So take a look at those. There's plenty of problems to practice on. And if you have any questions, as always, reach out to me. And there you go. That's complex numbers.